is. Okay, so how was everybody's first day yesterday? Good. How was the dismissal? Terrible. I keep hearing that. So a lot of congestion. The traffic is a problem. So again, just like arrival, dismissal, just try to give yourself a little extra time. Be patient. Once folks get into a rhythm of things, I'm sure we'll get accustomed to it. And by the time we're used to it, all that'll be gone. But it's only going to last 2 years, right? So it'll be gone like that. Yeah. Okay. All right, so what I want to go ahead and do, we went through the slides yesterday. Now, I'm not going to worry about going through the slides today. I'm sure you're doing those in other classes, and the orientations are going to happen tomorrow. So this class is pretty much going to be wiped out tomorrow because during fourth period, all of the sophomores are going to be called to the auditorium for that discussion. So we're going to go ahead and talk about our lesson today. We pretty much should wrap it up. You got the homework assignment. Your first quiz is coming up next week. Okay, so let me go ahead and show you this right here. If we're looking at our current week right here, see here's the real numbers. Okay, so this is the paper that you picked up on the way in, and that's, one of the daily routines. When you come in, any papers on that front bookshelf, that's what we're looking at that day, so go ahead and grab those. I see a lot of cell phones up in the caddy over there. I want to thank you so much. I really appreciate that. Remember, that's one of my expectations, that you don't have your cell phone with you at your table. Okay, it's either going to be up here in the caddy or it's going to be over here charging on the bookshelf. Okay, so I do appreciate that. So if you are one of the people who decided to go ahead and keep the cell phone with you, okay, you're not following my expectation. I mean, there's nothing I can do about that, but please make sure it doesn't come out. Okay, I do not want to take your cell phone. Now, the reason I'm going to go ahead and show you this very quickly, I'm doing this for all of our assignments. Okay, if you take a look, there's your homework key. Why would I provide the key to the homework? To check yourself. See, remember, the whole point of the homework, it's not to take up your time after school or anything like that. It's so you can work with the material, kind of understand what's going on, get ready for the quizzes, which in turn get you ready for the exams, in turn get you ready for other assessments that we have, like the district assessments. Okay, so we're constantly, building on this. So if you ever get stuck and you're not even sure, hey, am I doing this problem right? Log on and check. If you got the correct answer, fantastic. If it's not correct, come on in, let me help you out. We'll figure out where that miscommunication is. Okay. Remember, homework isn't taken for a grade anyway. Okay, so I've got no problem doing that to help you folks out. All right. The only thing I want to do before we go ahead and get to the lesson is just go ahead and very quickly talk about the syllabus, which we didn't get to do yesterday because we had a very shortened amount of time together. Okay, so hopefully you've had the time to take a look at this. If not, definitely kind of look at it when you have a few minutes. If your folks want to, it's also on the website, free copy to you. It's always open 24/7. Okay, so I'm just going to go through this super quick. The first part here talks about absences. So whether it's an absence that maybe is an emergency.
Sorry for this interruption. We need freshman students, alphabet M through R, up to the dining hall for Chromebook distribution and badges. If you have your badges, please bring them with you. Thank you.
Okay. So whether it's an absence, beyond your control, or if you're out of class because of a sports activity, what is a good way to help you with that? We were just talking about it. The thingy? The website. Go to the website. Everything that I always talk about, the notes, the video links. So by the end of the day, this conversation right here, if you're thinking, man, that was so much fun, I want to relive it, it'll be available to you by the end of the day if you want to do that. Okay, so all of this is always going to be on the website. Okay, moving on. Grades, we're going to be on a 90-10 scale because we have a district assessment every 9 weeks that we have to work towards. So 10% of your average will be the DA. It is going to show up on the report cards. I always encourage students to try your best. I believe we still have 2 days to go ahead and take that. I'm going to look into it. But everything else that we do, whether it's a daily quiz, grade, exam, all that's going to be the remaining 90%. Okay. Late work, we don't take late work for a grade. In fact, not only would you like to look at the homework, because it's practice, but if you ever get a failing grade in here, like next week, we're going to have a quiz which covers part of this material. If you want to retake it, well, then you just have to have the homework completed and turned in before the retake. Okay. So that's kind of my way of, making sure that you do look at the homework at least one way or another. You get some practice, you can ask some questions, and then you take your retake. Okay. But I mean, we're not taking it for a grade or anything. So if you never turn in the homework, technically you never have to worry about that. It's just if you want to retake a failing grade. And remember, it doesn't even have to be failing. As long as it's below an 80, you can retake. Okay. Cheating, we're not going to worry about that. Just if you're having trouble, please come talk to me. Let me help you. Maybe we'll find a way to get you where you need to be. Okay. Let's see here. Let's see. Supplies. Again, I would probably just say a binder because, of course, you see we're going to have skeleton notes that we just fill in together as we go. But it's probably a good idea to have some place to keep those, whether it's a folder. I say a binder, but wherever works for you. Food and drinks are allowed, but again, we do have mice in here, unfortunately. So, if we go ahead and make sure that there's no food or we clean up after ourselves, hopefully they go someplace else. Okay. Tutoring, I've got the tutoring on the front board. It's in the hallway. It's going to be all over the website. Monday, Tuesday, and Thursday mornings from 7:45 to 8:05. And the only times I can do after school are Tuesdays and Wednesdays. Okay, so those are my dedicated times. So unless there's something beyond my control, you come in during one of those times, I'm hopefully going to be sitting here at the desk or helping somebody out. Hopefully I can help you out as well. Okay. We already talked about the cell phones. Again, I can't thank you enough. That's fantastic. We're going to keep that up. Earplugs, we are going to make sure our earbuds are out as well because I know you can still connect to those. And, why would you want to listen to the hottest new song when you can talk about algebra? Right? I mean, man, kids today, I don't know. The one thing I'm not going to worry about are the smartwatches. I know that a lot of organizations, if you're taking an EOC, a state test, a national test, they are requiring students now to not only give up your cell phone, but also smartwatches because you can text on those, you can pull up internet, you can make phone calls. I mean, it's a wonderful time we live in. So I'm not going to go ahead and push it so far as the smartwatches, basically, unless somebody gives me reason to think I should. Does that kind of make sense? Okay. All right, good. And then if you ever need to contact me, patrick.west@lubbockisd.org. I'm usually really, really good on this. I pride myself on getting back to people as soon as possible. Now, the later you email me at night, definitely like 8:30, 9, and later on, I mean, you're more than welcome to still email me, but getting on late in the night, I'm probably not going to respond until the morning. Okay, unless I, just happen to be working or whatever the case is. And there we go. That is the syllabus. We talked about the slides yesterday. Are there any questions? Okay, anything about the school? Anything about the class that you need a little explanation on? Anything about the restrooms? Anybody have a question about those? They did make 2 changes. I'll talk to you about them very quickly because, it was understandable first day. We already had some parents who voiced some concerns. So one change that we've already made, how many passes do you get per day? Okay, well, you originally had 2, now you've got 3. That's one change. So you can go before school, during lunch, and you've got 3 passes throughout the day. In fact, I've got my iPad out over here. I'm going to go ahead and start playing with the system. So if you want to go to the restroom, just come on up here. Okay. You can go ahead and fill out the pass for yourself. I'll go ahead and approve it. I'm going to try it and see how it works. I think once we get a couple of weeks in, we practice with it, it just becomes second nature to us. So that's one change. The other one is, what was the one class where you couldn't go to the bathroom? 5th period. Why? Yeah, because it was understood you'd go to the bathroom during lunch. That's also changed now. So during 5th period, you can use one of your 3 passes and go to the restroom. There's a catch, though. Okay. The only bathrooms that will be unlocked during lunch are in the cafeteria. So depending on where you are on campus, if you're like in the 1100 hallway or the 900, you really don't have any problems because you're right there. This class right here, it's not a terrible walk. If you're in the science hallway, you basically got to cross the entire school to get over there. So just, keep that in mind. I think the passes are going to be, 7 minutes? I think is the default. So you don't want to try and take the whole 7 minutes in case somebody else has to go, but okay. But that's it. Any questions on that? Okay. Any questions in general? How we doing? Excited to be here? I can tell. Claire, what do you think? Oh, I know, but her head was down. There you go. Okay. What's up? Yes. There you go. You want to go to the bathroom? Okay. Let's try it. Of course, now it wants me to log in. Oh, you gotta be kidding me. I already had it set up, and now it wants me to go back in. Hot. I'm having to water my garden daily to just so it doesn't die. Okay, so let's see here. We're going to create a pass. Okay, we're going to go to fourth period. Okay, go ahead. Oh, no, hold on. Create a pass for fourth period. And what's your name? Jalen. So go ahead and start to type that in, and it should pop up. There we go. So we're going to click continue. So now we are going from 2204. And we're going to, what happened to the pass I just created? Okay, so go ahead and fill that out again. It took it out for some reason. See, this is why we're doing this, so we can actually get practice and see how it works. But I know what a lot of people are thinking, man, let's go ahead and get started with the math. Okay, I got you. All right, so let's say I want to make sure to be mindful of the time. We get out of here at 55. We got plenty of time to go ahead and get through this. So this is what we should be looking at right now. We're going to start with real numbers and their properties. So I'm hoping, so it should be second girls. Yes.
Okay.
There we go. And then you'll take this with you. How much time does the student need? So you're live. You got 7 minutes. Okay. All right. Well, let me go ahead and turn out the light. It's probably a lot easier to see what's going on here. So here we go. Real numbers. Like I said, hopefully this is going to be a little bit of a review. If it's not, okay, that's fine. Definitely ask questions if you have any. So real numbers, all of the number sets that we're looking at, they're going to have a specific letter to identify that. So when you see R, we're talking about the real numbers. And you've probably seen variations of that, you know, from time to time. You could even have that double R. Anybody ever seen that before? That represents all reals. A lot of different ways to go ahead and show this. But we got a lot of definitions here. So the real numbers consist of the following sets of numbers. Okay, so we have the irrational numbers. These are numbers in which the decimal form never terminates and does not repeat. That's two qualifications if a number is going to be irrational. The decimal has to go forever, and there's no pattern to it. Okay, and then we got some common examples. Pi is the perfect poster child when it comes to an irrational number. In fact, what is pi? Yeah, 3.1415926539826. Yeah, I can actually do it for a while. It's great at parties. Don't know the song. Never heard of the song. I guess it depends on the teacher. Typically, you know, the more decimal places you take, the more accurate, but that's a perfect example of an irrational number. The decimals go forever, and there's no pattern to it. It just looks like it's a bunch of random values. Okay. Now, rational numbers, these are numbers in which the decimal form either terminates, so it stops, it doesn't go forever, or if it does go forever, it repeats. Okay, so basically a really good way of thinking, is a number rational? Can it be written as a fraction? Okay. If you can write it as a fraction, it's going to be what we call a rational number. Okay. Now there's one thing here, the numerator and the denominator, that A and B, they've got to be integers. Okay, so what's an integer? Here's the set of integers. So think about all the way back to kindergarten, when you first were introduced to these ideas. You were first introduced to just your counting numbers, 1, 2, 3, 4, and so on. Those are called your natural numbers. And then as you got older, okay, your knowledge got bigger because you were exposed to new things. So after you learned to count, well, then you learned there's a possibility of nothing. You were introduced to the idea of zero. And then you continue to move off of that. Not only do you have the positive numbers and zero, but the integers also have their opposites. You started to look at addition and subtraction, things of that nature. Okay. Now here's the thing about these three groups right here. Okay. For all three of these groups, okay, this is going to be everybody's favorite. No fractions or decimals. Okay. For all three of these groups, integers, whole numbers, and natural numbers. So if you come across a decimal, it's not going to be an integer, natural, or whole. Okay. If it's a fraction, now I say there are exceptions. If it's a fraction that can be simplified to a whole number, well, yeah, then it's going to be rational. But if it's something like 4/5, that is not an integer. Even though the numerator and denominator individually, 4 and 5, are integers. Does that make sense? Okay. Now, it uses this word here, subset. Anybody tell me what that means? Now, instead of the word subset, you might see certain texts that'll say subgroup. Does anybody tell me, like in your own words, what that is? A set underneath a set. Okay, very good. So you're talking about one set or group contained within another larger set or a larger group. Kind of think about this campus as a whole. Every single student, doesn't matter about age or classification, whether junior, senior, whatever, we're all Lubbock High students, right? So we form one giant 2,000 plus group of Lubbock High students, but only you folks belong to this fourth period Algebra 2 class. So we form our own group, but this group belongs to the larger group. You're a subset or a subgroup of the larger. Does that kind of make sense? So the same thing here when you're talking about natural numbers, all these natural numbers, I find them in the next biggest group. The groups start to get bigger, but the previous group is found inside of that. Okay? That's what it means when we're talking about a subset or a subgroup. Hey. So now, when you come back, Jalen Gibbs. Get the pass. There we go. First test, off to a little bit of a rocky start, but we got it. We're good. Okay. All right. So let's go ahead and look at these in a little more detail. Now, the one thing I do want to say, I put a little asterisk right here. Irrational numbers cannot be expressed as an integer over an integer. Okay. Remember, new fractions. All right, so here's visually how we can organize the real numbers. And this kind of goes along with what we were just saying, how you have the smallest group in part of another group that's larger. So you'll see the smallest subgroup is the natural numbers, which belongs to the wholes, which in turn belongs to the integers, which in turn belongs to the rationals. Okay, so each of these groups is going to have its own identifying letter. Okay, so the naturals are N, the wholes are W. So far, so good. But the integers, we use a capital Z. So every time you see the capital Z, we're talking about the group of integers. Your positive counting numbers, 0, and their opposites. For a rational number, we're going to go ahead and use Q. But irrational, now some of your previous teachers may have said that irrational was going to be a capital I, and there's nothing wrong with that. But the further we get in here, if I were to go ahead and use a capital I, what is that going to better stand for? Imaginary. Okay, so we're going to be getting to the imaginary numbers soon, so we don't want to confuse you on that. So that's why we're going to go ahead and say that the irrational numbers, we're going to say it's Q prime. Okay, and then I went ahead and gave you an example of each of those sets right there. Now, if we're looking over here at this diagram, I already talked about the subgroups or the subsets. So you'll notice this right here, what's Q prime again? Irrational. The irrationals form their own little group. If you go ahead and identify something as irrational, it doesn't belong to any other group. Okay? So if it's irrational, it'll never be an integer. If it's irrational, it'll never be a whole number. But our entire universe, all of this is housed as a real number. That's what the rectangle represents. Because no matter what number you give me, it's always real. Now we can classify it in different ways. Now some people like this, where you can visually see the circles. This is how I was taught, and maybe this looks a little more familiar. This is the hierarchy. This is just another way to visualize those groups. Okay. So we start with everything is the reals. Now the reals are broken up into two groups, either the rational or the irrationals. So you remember what I said about the irrationals? If we say something's irrational, you'll notice, does it have any subgroups? No. So if it's irrational, you're done. Okay. But if you say that a number is rational, if it can be written as a fraction, could it be an integer? If it's an integer, is it a whole number? Is it a natural number? So it's almost like you got to work your way down that chain there. Okay. Does anybody remember doing stuff like this before? No? No? Okay, so some people. Does it make sense then? There we go. Guess you could say it just got real in here. I got a lot of them. Just wait. It's going to be awesome. Okay. Oh, this is busting. Okay. That's no cap. See, I'm still with it, you know. I know the teenage mind. It's awesome. Okay. All right. Watch me cook. Okay. So practice. Name all the sets to which each value belongs. Okay. Now, a lot of times, you know, when we have this many examples, if we have time, I would definitely, you know, go through every single one of them, or if you ask me to. But a lot of times I'm thinking, once everybody starts to feel confident and comfortable, we can go ahead and move on. We don't have to do every single one of these. Now, I've got the first 9 highlighted, so we'll just kind of go from there. Okay. So number 1, -10. Okay. Now, you can start wherever you'd like. Now, me personally, this is what I like to use. You can go ahead and start from the bottom. I like to start from the top and kind of just work your way down. Okay. The reason I like to do that is because is everything I come across, is it always real? Yes. Everything you come across is always real. So at the very least, I can go ahead and say, yeah, that's real. That's real. That's real. As long as it's a value of some type, it's always going to be real. That's why I like to start there. Then I just make my big decision. Is what I'm given, is it going to be irrational or is it going to be rational? Okay. What do you think about -10? It's rational because by definition, could I write -10 as a fraction? Yeah. If you want to make anything a fraction, I can put it over what? What? And look at the definition. Okay. Put it as a fraction a over b, where a and b are both integers. -10 is an integer. Is 1 an integer? Absolutely. Yeah. And, you know, in the beginning, if it helps you out, if you want to go ahead and draw that hierarchy, okay, there's the rational, there's the q prime, and we'll just kind of go down. So we already said we chose real. We also said it's going to be rational, so we're not going to worry about that right there. Okay. Is it an integer? Actually, I kind of gave that away. Yeah, it's an integer. I mean, if you just go ahead and look at the definition, right here, what does this ... mean? It means it's going to continue that way forever. So -4, -5, all the way to -10. Okay, so this is an integer. Remember that z. Okay, so it's an integer. Is it a whole number? Why not? The whole numbers and the natural numbers contain no negatives. So you can only classify it to those 3 groups. That's it. That's all you want to do. It's not bad, right? Okay. Okay. Well, let's take a look at the next one. Now, square root of 30, definitely real, but we have to decide rational or irrational. I'm thinking irrational. A good way to tell if it's irrational, if it's a square root, it's not a perfect square root, like square root of 4, square root of 16, square root of 25. Square root of 30 is going to give you a what? A decimal. Now, if you want, I can pull up what that decimal is, but I don't think it's necessary. In fact, by definition, it said that square roots that were not perfect squares, they're going to be irrational. Okay. I mean, personally, I like decimals. I mean, they have a point. Oh, okay. It took a second on that one. They have a point. Okay. Now, here's my question. Remember, here's the hierarchy. Whether you're looking at this or you're looking for, we said real. We said irrational. Can I even go any further? If we say something's irrational, we have to stop because there's no subgroups or subsets for the irrationals. Okay. Perfect. Okay, now this is a mixed number. Okay. Now some of these you're going to come to find out, maybe we could simplify or we could rewrite those. How could I rewrite 1 7/9 as an improper fraction? Anybody know what I mean when I say that? Okay, how'd you get that? Okay, so this would be equivalent to 16/9. That side of the board is a little weird. Let me see if I can write that better. 16/9. So you may remember this is a mixed number because you have a combination of a whole number and a fraction. Okay. If you start with the denominator, you multiply by your whole number and then you add the product to your numerator. So what's 9 times what? 9. And then plus 7, see, that's where the 16 came from. Okay. And then if I wanted to go back, 9 will divide into 16 only once with a remainder of 7. And you put the remainder over the divisor. Okay. So now it's an improper fraction. Why am I using the term improper? What does that mean? There you go. If the top number is bigger, that means it's improper. Okay, so we got ourselves a fraction, real or irrational. Or excuse me, rational or irrational. It's rational. So I'm going to go ahead and say Q. Okay, now remember, we're moving down the line. The next subgroup or subset for the rationals is the integers. Is it an integer? Or not? Remember, integers, whole numbers, natural numbers, they will never be fractions or decimals. Okay, so because that's a fraction, that's where we stop. Okay. Now, do you notice anything about number 4? What is 24 over 8? 3. That could just simplify. So see, sometimes they may throw one of those at you just to see, if they can catch you. So it's definitely real, rational, or irrational. That's definitely rational. I could write that as a fraction. What's the first subgroup after the rationals? Is it an integer? Yes. What's the next group? Is it a whole? It's a whole. What's the last one? Is it natural? Yeah. So this one actually belongs to 5 sets. Okay. Anybody having a hard time? Easy? Didn't remember math being this fun, right? Okay. Let's try the next one. So this one is a decimal. First off, we already said it's real. What do you think? Rational or irrational? But it's a decimal, so why is it rational? Now remember, it's only irrational under 2 conditions. The decimal has to go how far? Forever, and there can't be a pattern to it. So while this one is a decimal, does it go forever? No. So this one right here, that's going to be irrational. Okay. What about integers? Nope, because remember, integers, whole, natural, no what? No decimals, no fractions. That's it. Okay. What about number 6, the negative square root of 81? Okay. Well, first off, how would we simplify that? What is the negative square root of 81? Negative 9. Why wouldn't it be 9i? Why isn't this imaginary? You remember what I'm talking about? Okay, so maybe I don't want to do that right now. Because the negative is on the outside, I'm just going to go ahead and keep it there. The square root of 81 is 9. Is everybody okay with that? So we'll just kind of skip that other part for right now. Okay. So we said it's real, rational, irrational. Rational. Is it whole? Excuse me, is it an integer? Yes. Is it whole? No, because wholes and naturals don't contain what type of numbers? Don't contain negatives. Okay. Let's take a look at 7. Now, this is another one very similar to 4. What's pi minus pi? Anything minus itself, wouldn't that just be 0? Okay, so anything I come across, it's always what? I always start with the real. Is it rational? Yes, because even 0, I can make it a fraction by putting it over 1. 0 divided by 1 is still 0. Okay. Is it an integer? Yes. Is it a whole? Yeah. Is it natural? No. The only difference between the wholes and the naturals, the wholes have 0. The naturals will not. Okay. How are we doing? Great. Do we need to do any more of those? Or do you see one you would like to do? No, we're good. We starting to get the idea? Fantastic. Okay. Well, let's take a look at this right here. So you've got properties. Basically, you've been using rules for a long time, but all these rules in mathematics, they have names on them. Like, for example, have you ever played a game, like any kind of board game or even a video game? You sit down, there's rules associated with it. There's symbols and all kinds of things that you have to come up with. Well, mathematics is no different. Think of it as one giant game. Okay, what we use, they have names. Okay, so we're going to break this down into 2 categories. Either it's going to be an addition example or a multiplication example. Okay, so commutative simply means we can switch the order. So if I'm talking about addition, if I have a plus b, that equals b plus a. Now we're just using variables because we want to say that this represents everything in general. Like if you give me 2 numbers, any 2 numbers. 2 and 7. Will 2 plus 7 equals 7 plus 2? Yeah, changing the order doesn't affect the outcome. Okay, we call that the commutative property for addition. Or if you want to, just say commutative addition. But for these first 4, okay, when you're going to go ahead and use one of these, you also have to say whether it's addition or multiplication. And multiplication is just as straightforward. A times b equals b times a. So would 2 times 7 equal 7 times 2? Yeah, the fact that I switched the terms has no effect on the outcome. Okay. Now you'll notice commutative subtraction, that doesn't work. Because, for example, what's 2 minus 7? -5, but 7 minus 2 is 5. So see, you don't get the same result, so that's not a specific rule. Does that make sense? Okay. So anybody think they know what am I going to be dealing with associative? Fractions could be part of it. Parentheses, we're going to be talking about groups. So if I regroup certain terms, it's not going to affect the outcome. So if I add a plus b as a quantity and then c, that would equal adding quantity b plus c and then adding a. Okay. And it's super easy. Just give me 3 numbers. Okay, so let's say 1. So I'm going to use 1. What's for b? 1, 5, and 2. So let's say I have 1, 5, and 2. So according to this rule, if I say 1 plus 5 and then plus 2, would that equal 1 plus 5 plus 2? Yeah. The order in which I add those has no effect on the outcome. So if you're switching the group around terms, that's what we call associative. Same thing when it comes to multiplication. Instead of adding, you're just multiplying. So I could go ahead and say 1 times 5 and then times 2 equals 1 times the group of 5 and 2. Remember, because order of operations, which we're going to talk about next week, that just tells you where to start. You always start with exponents, parentheses, all that good stuff. Okay. So is this making sense? Okay. What about identity? Anybody think they know what that might be? That's okay. That's okay if we don't. This thing will come down. This means, can I perform an operation and end up with what I began with? Okay. So how can I add, but the result's going to be the value? So yeah, if I add 0 to anything, I get the original value. Okay. That's the additive identity. If I multiply anything by 1, I'm going to get the result I started with. Okay. That's the multiplicative identity. Okay. Inverse. Now I'm going to be specific about these in a second when we get down below here, but Basically, the inverse for addition, that's the opposite. Okay. The inverse for multiplication, well, let me bring that down a little bit. What's the relationship between 1 and 1 over a? Starts with an R. They're reciprocals. Okay. So when it says additive inverse, that means opposite. When it says multiplicative inverse, that means reciprocal. How can I perform the operation and get a result of 0 or 1? Okay. And then, of course, distributive, you've been using this for a very long time. That's just if I have some outside term, I multiply by every term in parentheses or brackets. Okay. And we're out of here. 55. Oh, we will definitely finish this before then. Okay. All right. So the next set here, all we want to do is, given an example, we just want to go ahead and figure out what property is this talking about. Now remember, if you say it's commutative, associative, identity, or inverse, you also have to tell me whether it's adding or multiplying. The only one you don't have to add adding or multiplying is if it's distributive. Okay. So let's take a look. So I've already got these written out right here. So let me pull this down a little bit. Let's take a look at this first one. So it says 5 times 2 times 8 equals 5 times 2 and then times 8. So we don't want to say it out loud. We're going to do both of these at the same time so that when I pull down that screen, we're going to be able to see the answers. So what I want you to do is run through this table. Which rule does this look like? What rule says that I can group terms differently using this specific operation and get the same answer? And then for number 14, we have 6 times 3 minus 7. So that became 6 times 3 minus 6 times 7. Okay. So think about what that's going to give me. Okay, show of hands. Who thinks they got number 13? Okay. Help me out, sir. What you got? It's what? Associative. Okay. It is associative, but for what? Are we adding or multiplying? So it's associative for multiplying. Remember, associative is when we're using groups. Okay. What about number 14? Who can help me out with that one? Okay, Claire, what you got? That's distributive, yeah. I'm just multiplying the 6 across the terms inside that parentheses. Associative multiplication and distributive addition. Okay. Now, you don't have to technically add that because it was subtraction. I put that. But if it's the distributive property, distributive is fine. Okay. All right, let's try a couple more of those. Let's try numbers 15 and 16. Give me a little bit more room here. Okay, so 15 says 7y plus negative 7y equals 0. So it looks like we're adding two terms and they're canceling each other out. I'm getting 0. Okay. For number 16, we have 3a plus 2b equals 2b plus 3a. So here they're just switching the order, but it's still the same. Okay. 2b or not 2b, am I right? You know, I'll tell you, this isn't an English class, but it's going to be lit. Literature. Come on, that was good. That was good. A little bit. Okay, I'll take it. Okay. All right. So looking at these two rules right here, what are they trying to get me to think of from that table? Pull this back down a little bit. Now, I will tell you, you'll notice you do have parentheses here. You got a group, but you want to be careful. Just because you have a group, don't automatically go to associative. Okay? Because we're not switching terms using that group. Okay? So which of these says that I can add something and it's opposite? It's the inverse for which one? Inverse for addition. Yes. Okay. What about the 3a plus 2b equals 2b plus 3a? Which one says that I can simply switch the terms and have the same thing? Commutative, but adding or multiplying. Okay, multiplying. Because remember, again, if it's commutative, associative, identity, or inverse, we do want to put, is it adding or multiplying? Okay. And really, when you think about it, division is just multiplication. Okay. Yeah, really. Because think about it. Let's say if you want to go ahead and divide by 2, isn't that the same as multiplying by 1/2? Yeah, they go hand in hand. If you really think about it, there's no such thing as subtraction. You're adding the opposite. Right? It's crazy. All right. So what do you think about these? Do we feel pretty confident with that? That's not too bad, right? Okay. And you got a couple other examples here. You know, if there's one that you wanted to look at, you know, definitely let me know. But we are running out of time, so I just want to go ahead and kind of wrap this up. Okay, name the additive and multiplicative inverse for each number. Now, I went ahead and stated this earlier, but I went ahead and wrote it down specifically here. When it's talking about an additive inverse, it wants the opposite. So that means you're changing the sign. Positive becomes negative and vice versa. Okay. If you're asked about the multiplicative inverse, that wants the reciprocal. So what that means is we take the top and the bottom, the numerator and denominator, and we do what? We just flip it. That's exactly right. But with a reciprocal, the sign doesn't change. You only flip the top and the bottom. Okay, so for 21, we have a -8. So when it's asking for the additive inverse, basically it's saying -8 plus what would give me 0? Yeah, 8. See, that's the opposite. That's the additive inverse. See, it's stuff you already know. We're just putting names to it, terminology. Okay. Now it wants the multiplicative inverse. So right now, if it's not a fraction, well, maybe we could make it a fraction. So what would the reciprocal or multiplicative inverse of a -8 be? -1/8. That's it. We just flip it. Remember, now when you take the reciprocal, the sign doesn't change. But when you take the opposite, all that changes is the sign. Okay. So what about 22? What's the additive inverse for 2/3? -2/3. Yeah, that additive inverse is the opposite. What about the multiplicative? That's 3/2. That's the reciprocal. See, that's all it is. Okay. How are we doing? Great. Fantastic. So again, you've got 23 and 24 if you want to take a look at those. But again, because this class is going to be wiped out tomorrow, I'm going to go ahead and just kind of wrap this up. Everybody seems to be doing pretty well. Okay, so we got some true and false questions here. This is how we'll finish up today. If it's false, give a counter example. What does that mean? Not exactly right, but it's an example that would prove that wrong. Okay, so let's take a look at 25. Integers are closed under multiplication. Now, what this means is if I multiply 2 integers, the result should be an integer. It should stay in its own group. Okay, so now think about it. Is there any time, thinking about the integers, the positive counting numbers, 0 and their opposites, is there ever a time where I could multiply any of those 2 and the result would not still be an integer? You think you know one? No? Okay, and that's correct. Because give me any 2 integers. 2 and 7. What's 2 times 7? 14 is still an integer. That's why we say it's closed, because it belongs to its same group. Okay. So let's try 26. Irrational numbers are closed under subtraction. Okay, now remember, irrational numbers, they're going to have an infinite decimal and no pattern. So if I go ahead and subtract 2 irrational numbers, will I always get an irrational number? Now let's think about this. What's the most famous irrational number? Pi. Okay. So let's take this for example. What happens if I take pi minus pi? Equals 0. Is 0 an irrational number? No. See, that's a counterexample. This goes against the rule. I proved that that's not always the case. So that's false. Okay. In fact, for the other 2, and you can go ahead and take a look at these, both 27 and 28, they're going to be false as well. Okay. All right. Well, how do you think it went for our first lesson? Great. Okay. Like I said yesterday, folks, I'm looking forward to having a great year. I hope you are too. If you have any questions or difficulties, please don't hesitate to ask. That's it. The bell should be ringing in less than a minute. If you want to go ahead and get your cell phone, please do so. I'm going to get set up for the next class. I'll stop this recording. Yes, the hole punchers are right up there. So the homework, I'll talk about it on Monday. But again, basically at that point, it'll just be kind of a review. So that one isn't officially due, but you do have it for practice.